Thank you for joining. This is Lucian, and I want to welcome you. You're the speaker. Thank you all for supporting the event. I'm going to pass on to your moderator, Joe. You got the floor.
Thank you so much, Lucian. Good morning, good afternoon, and good evening, and welcome to our session on the manufacturing analytics journey, which I'm sure you'll all get some real insights from. And insights are really what this event is all about. Insights are what you get from our organizers, IIoT World, which we rely on to give us the latest industrial Internet of Things, virtual conferences, and content. IIoT World has amazingly built a global community of some 200,000 decision makers and influencers across manufacturing, energy, smart infrastructure, cities, and buildings. It also delivers daily intelligence on IIoT, artificial intelligence, augmented reality, predictive analytics, digital disruption, cybersecurity, and machine learning. So that's a lot of insight. Insight's also what the company I represent, Aether, is all about. We offer an OS for frontline teams that leverages AR, AI, and the power of IoT to collect data, analyze it, and deliver relevant insights across industrial enterprises. Insight's also a big part of what our first speaker, Willem Sundblad, CEO and co-founder of Odin Technologies, will talk about. Willem's company aims to empower manufacturers to make more, waste less, and innovate faster through machine learning and applied analytics. He's also a leading voice in industrial IoT and is pioneering the use of real-time and predictive analytic tools that uncover untapped value. Recently named as one of Forbes 30 Under 30, Sundblad is also working to transform the manufacturing industry by digitizing, analyzing, and perfecting peak factory performance. Willem will also talk today about how the insights gained from advanced analytics can improve profitability. Take it away, Willem.
Sorry, I managed to mute myself. Thank you very much, Jeff. All right, let's kick things off. So, very excited to be part of this manufacturing analytics journey and track here. I'm going to start with a little bit of the why and a little bit of the how to get started. We ran our own state of manufacturing survey across a lot of different manufacturing executives. And it's no surprise maybe that we've seen that there's been an increase in the importance of digital transformation and digital tools for manufacturers in the last couple of months. The interesting thing, though, is that the value that they've been able to get from these tools have always been there. But COVID has certainly become a big catalyst for transformation because it went from being a nice to have or something that you theoretically can implement to something that was a clear necessity in order to make more with fewer people exactly on the factory floor. So we saw that 71% of manufacturing, so that digital transformation has increased in importance in 2020, and that they've actually moved up their investment plans. We're seeing a lot of manufacturers who are investing heavily in expansions in 2020 and 2021, because it's now a big factor in their business continuity plans and how they can operate while most of the workforce is working from home. The top aspects of digital transformation that we see amongst our customers is that they want to reduce operational cost by removing manual processes, improving quality by reducing process variations, and real-time performance benchmarking. Those are the top 3 reasons to drive digital transformation projects. Let's go into the advanced analytics itself. So we often look at it as 3 different buckets of diagnostic analytics, predictive analytics, and prescriptive analytics. A quote that I often steal from one of the co-founders of Spotify is, "The value of your company is the sum of all the problems that you solve." I think that's extremely true, and it's especially true for manufacturers. So if you look at diagnostic analytics, really what you're trying to do is you're trying to solve problems faster through immediate access to the right root cause analysis, the process improvement analysis, anomaly detection, and product traceability for your teams of engineers and people on the factory floor, so you can speed up that iteration cycle and solve problems faster. This is usually where you get the initial bump of ROI when you're starting to implement some digital transformation project. It's very common that even without advanced analytics, just normal traceability and transparency, that you get a 15% increase in yield just by the nature of observing the process more closely. Predictive analytics has been talked about for a long time, and one of our speakers is going to go through the history, particularly about predictive maintenance. One of the things that we as a company focus on more is actually predictive quality and performance and scrap. The reason why is because for a lot of companies, the data for how to actually predict a quality problem is usually a lot more available than for a maintenance problem, and the problem happens a lot more often. So whether you have a process where you can measure quality as it's being made through lasers or other tools, or if you have to take samples and test it in a lab and you might have a big lag, predictive quality can usually drive tremendous results to your profitability, because ultimately it's the bottom line of the trust of your customers that you're talking about. We've seen tremendous results in actually predicting offline QA results and translating that into real-time predictive scrap scores, so that the customer always knows that they're not going to underproduce or overproduce on any given work order. The next level, when you can actually predict problems, is the prescriptive level. So this is where you can actually prescribe the right actions to take in order to achieve a desired outcome in the future that is more profitable than what you were going to do before. Now, prescribing the right actions is ultimately what a lot of people are calling the Holy Grail. Because in reality, when we're talking about digital transformation, the value is only going to come when someone takes an action that is different and better than they were before. And so faster we can actually prescribe the right action to take, the faster you're going to get value. One of the things that we've seen in terms of changing the behavior here is that it's very valuable to actually present whether it's operators or engineers, the people who are interfacing with a digital tool with the opportunity cost of the recommendation that you're making. Because if you're showing, here's an opportunity that can improve your production with 10% in yield, it is very hard, at least not to consider making that change. And so the more concrete you can do that, whether it's in hours, dollars, or percent, try to always make sure that you're showing them the opportunity cost of not making the change. This is also obviously key in driving the whole digital transformation project in the first place. Because if you don't know where to start, or if you don't have that business case in front of you, it's going to be much, much harder to get everyone on board. But so when we're looking at creating these advanced analytics opportunities, you're most likely starting with a lot of data silos in the organization. So you have, an ERP system, you have an MES system, you have HMI or SCADA systems, and you've got an automation layer or data sources in the form of sensors that all needs to be tied in together. And one of the things that's really important as you're doing this, especially if you are a big organization with a lot of plants across the globe or even within a country, is to actually standardize and structure on a common taxonomy so that you can actually build scalable solutions for machine learning and AI that can actually transcend borders or at least factories. Because a lot of the advanced analytics that we're going to talk about here are built upon the availability of data and how much data you have. So the more you can standardize and structure across an organization, the faster you actually build up the data sets you need. So we actually have a poll for you here, because two of the interesting things is to understand where people are in the journey from a people perspective and from a technology perspective. So Jeff, if you want to launch the poll that we have. Great. So the first question here is, who is actually leading the initiative? And what type of infrastructure do you currently have? As we're getting the results from this one of the things that we've seen in the past year or so is that more and more companies are focused on really centralizing their data infrastructure in order to facilitate this digital transformation. It's really the utility behind a lot of the other advancements, whether it's AR, AI, or just visibility in general. And more companies are centralizing on OPC servers or tying in together the existing tools that they had, whether it was quality systems, historians, or MES systems. But ultimately, digital transformation, the key behind the success here is to make sure that, that you have the right leadership buy-in. So let's see what we have for results. So I'm going to go back into the presentation here. So what we saw is that the winner in terms of who is leading it is actually IT with 36%, 34% a distinct digital transformation group. Engineering and operations are about equal in 28 to 27%. It's interesting because a lot of companies are doing this differently. And in terms of, do you have a centralized data infrastructure? We've got 32% have no centralization, and the rest are either in a SQL database, data historian, or OPC server. And I think that's usually the place to start, is really, you know, how you tie all of that data in together. And the interesting thing is that you're going to be looking at different types of data in order to actually produce the recommendations and insights that we're talking about with advanced analytics. You've got real-time process variables coming from the machines that are maybe today in a data historian. And you've got metadata that is extremely important for the analysis of that time series data. That's going to come from ERP systems, MES systems, or other tools. But just centralizing the data doesn't actually give you any value. It's really all about giving access to the right people at the right time. And so what we talked about before with the diagnostic analytics, having people have access to easy to use visualizations, easy query language or query tools usually gives you a huge bump initially. But it's in the advanced analytics where you find the really differentiated value, where you go beyond solving the low-hanging fruit. So the connected operations is where you start with the benchmarking and the visibility. If you can predict certain events, have alerting in place for simple rules and anomaly detection, you can start solving some of the harder challenges. But it's really with the prescriptive operations where you can actually have the symbiosis of the domain knowledge of the engineers and the complex analysis of the tools working together to really change that workflow. Because a challenge for a lot of manufacturers is that the workflow of actually making products spans many different personas and it spans many different business systems. So you really need to tie it in together into a cohesive platform and then have the right tools to make the right recommendations to people. Because you're producing data on the order of millions of data points per day per production line, which means that it's just too much for a person to actually analyze. And so you need the combination of smart systems that finds what we often call the look here, look now information, and finds those recommendations of where to improve, how to improve, and what's next. So one of the critical parts of that is the machine learning lifecycle. So, and this is also true for digital transformation in general, that it really starts with identifying why you're doing it in the first place. You have to have a clear business case, or you have to have a clear use case. For us, it's almost always around quality and performance, just because we can drive value very, very quickly there. The data is automatically cleaned and contextualized and structured so that the data pipelines can actually take it up and build, and we can launch scalable solutions or applications that drives results. The training and deployment of machine learning models is actually the most critical part here. And the critical part is that you have a short iteration cycle and how long it takes you to do it. Because it's not about having the best model, because if you have the best model, but it takes you 3 months to iterate on it, it's going to be obsolete, because really it's actually built on the data set that you have. So make sure that you have an iteration cycle on building, training, and deploying new machine learning models that's in the order of hours or days, not weeks or months, because that's the way you're going to make sure that you're always on top and that you have a continuously moving goalpost of your competitive advantage. In the same way that training and deploying of the machine learning models and the fact that that needs to happen in the cloud and on the edge, you also need to make sure that those insights really go to the right people so that you're fitting into the existing workflow. Because there's going to be one person who's going to probably be doing the analysis and another person who's going to be executing it. So how do you make sure that those people are communicating with the right level of context and the right level of information so that that can happen very quickly? And ultimately, this is a continuous loop of optimization where if you've got the right infrastructure, you really get a Cambrian explosion of potential solutions to problems that was previously just too complex for you to solve. And you might start with a simple predictive quality use case, but all of a sudden you've hit more and more challenges that your people couldn't solve before, in creating automated insights that drives real tangible actions, that drives real results instantly. One of the questions that a lot of people ask is, where's my competitive advantage if everyone is using the same tools? And ultimately, even though manufacturing, especially within verticals, can be quite commoditized, there's still a lot of unique characteristics in terms of your own factory. And so when you combine your own machines, your own metrics, your own targets, really the intellectual property for how you make your things, which is your process data, with that shared infrastructure, you do create a unique model. So an example that we provide to our customers is something called Golden Run. It's a machine learning model that looks at the way that you make a product. It finds what the opportunity to improve that product is in terms of speed and quality optimization, and prescribes the right process settings to achieve that. And we've proven that we can drive 15 to 40% increases in yield through this Golden Run model. But even if we deploy this model to two customers who are in the same industry, it still produces different results because it's using their own data to actually generate the results. So the shared infrastructure is where you get the economies of scale of not having to build everything yourselves, but you're still building a unique competitive advantage and differentiation in how you're leveraging the data to take better decisions and actions faster. So some takeaways here. I think that the thing to start with is always finding the right problem to solve. Because even if you are along the way on the journey, you want to make sure that you're continuously driving the right actions and the right ROI. And if you're earlier in the journey, you might be the champions who are trying to bring about this change in the organization. And so you need to prove value quickly. And the fastest way to get everyone on board is just to show ROI. If you've got the right problem to solve, it's way easier to get everyone on board also in terms of what data needs to be ingested or integrated. And so you can start that connectivity of the infrastructure. The targeted projects that can scale is critical because you want to keep momentum. As an example, we had a customer who just had a 5-week payback on a pilot, or actually on a 5-week payback on a yearly project, because we had identified the right problem to solve, connected the infrastructure very quickly, and managed to prove that so that you can take that and scale it up beyond that first pilot use case. So if you follow that journey, you're going to see a lot of success and you're going to see a lot of support coming from your organization. I think that's it for my 20 minutes, and I'll be back with the Q&A later.
Thank you so much, Willem.
Thank you.
That was a lot of insight on deriving insight from analytics. Next up is Marcia Gadbois, President and General Manager of Adisra. She's an entrepreneur who's successfully grown a startup from inception to a successful liquidity event. Prior to joining Adisra, she was president of Indusoft, which was acquired by Invensys. In the past, Marcia has held a number of high-tech senior management positions in the area of business development, strategy, competitive intelligence, marketing, and sales. Today, she's going to help us understand how to gain insight into the future with a look at the evolution of predictive maintenance It's all yours, Marcia.
Thank you so much, Jeff. As Jeff said, my name is Marcia Gabois, and I am the president of Adirshra. Adirshra offers tools in HMI SCADA, OEE, as well as advanced analytics and predictive maintenance. When you, oops, I'm sorry, let me advance those slides. Okay, thank you. I apologize, I just had technical errors, please. Let me advance. For some reason, I'm having a hard time seeing the cursor. Thank you. When I first started in AI in the 80s, I'm dating myself, I know. I worked on a product called VAX Decision Expert, which was also known as GenX. GenX was a joint venture between General Electric and Digital Equipment Corporation. Digital productized this tool. And what it did, it was a knowledge-based kind of tool that used, consists of a collection of production rules and had an inference mechanism, and it did both backwards and forward chaining. GenX was used in many predictive and diagnostic applications, such as gas turbine, aircraft engines, aircraft controls, even washing machines, and refrigeration diagnostic. An example of this application using GenX is the steam turbine expert system. This system used all the available turbine monitoring information, such as phase angles, it did temperature, it did shaft monitoring, it did temperature, it did vibration readings from various machine running states. The system extracted features from this data and stored it into the knowledge base. And then the rule-based system would automatically take it off and extract from that data, indicating if there was a flaw in the system and in the condition of the turbine, and then examine these features for more details of the specific flaw and associated with the cause. Excuse me, I'm sorry. This is doing root cause analysis. The system provided an in-depth diagnostic of fault, such as rubbing, misalignment, instability. It did monitoring problems. It did mounting problems, oil will, etc. The system also automatically, when it found a flaw, would schedule for repair. It followed the model of diagnostic analytic as described by Willem from Odom Technology in the previous presentation. This rule-based system reached the point that it was unmanageable. Engineers were afraid to delete any rules because they didn't know what would happen to the system if you deleted a rule. So in turn, they kept adding new rules that oftentimes were redundant or became too unwieldy to manage. So after a time, the maintenance of this system became very, very difficult to maintain. I believe that this type of application that I'm describing here is perfect for machine learning systems. You can build a system where you have a set of parameters and you have weights. You can train a model based on a particular outcome that you want to achieve, and you can also modify when the outcomes are changing. It becomes easier to maintain than a rule-based system in this particular scenario. A lot of time people think, and I hear this a lot, that machine learning using algorithm is the panacea for all problems out there, but sometimes it is not. There are times when rule-based systems or even deep learning are the answer. Advance to the next one. Can someone help me advance? I'm having, thank you. I'm not really a terminology buff, but I went ahead and decided to define on this slide what I mean by these terms. Rule-based system is really a set of rules that are just if, then, else statements, while machine learning is being able to detect patterns and rules to data to predict future outcome or data. While deep learning attempts to mimic how human learns, such as neural networks, such as artificial neural networks or recurrent neural networks. I will not be speaking about deep learning in this particular presentation for the sake of time. My main point is that all of these types of software methodology are useful in the right circumstance. Can someone advance to the next slide, please? One back, please. Rule-based. I'm really sorry. Sorry about that. Rule-based systems are used in many diagnostic and fraud applications. It also is used if you've ever gone to get a loan from a bank. It really is a lot of times a rule-based system that they're using, based on the information that you provide them. They give you a results that you either approve for the loan or you're not approved for the loan. That is a typical rule-based system. It does require that you have a set of rules or an expert that knows the rules that you can interview to get the rules from them. It is a deterministic system that is based on this input, you give it, here is the results. It is great for small to mid-sized applications where there are not a lot of rules. You can determine how many rules is too many for you to manage. I like to say about 100 rules or less, because if it's more than that, it becomes a little too difficult to manage. And I tend to see people starting to add redundant rules to the system. And in my previous example, if it gets too big, it really does become really unmanageable for anyone. The advantage to a rule-based system is that it is a lower effort. It definitely is more cost-effective and less risky, since rules won't change or update on their own. However, rules can limit AI's capability to be a very rigid intelligence. And what I mean by that is it's only as good as the rules you put in it. So it will come up to the conclusion based on the rules given the data. Also, all rule-based systems are like a little child in that respect, that you can tell them you can only have 2 pieces of candy. That's the rule. Fraudster will try to get around the rule. So you need to constantly be updating to alleviate some of these fraud, as well as environments change. So whoever expected this pandemic to happen, so that environment change. So if the environment is constantly changing, you're going to constantly having to add new rules to the system to take advantage of the new environment. Next slide. Thank you. Machine learning. Machine learning is good for predictive maintenance, where historical data along with real-time data can be used to predict failure rate of a part, machine, or even a process. It does require you to have a lot of data available to train the models. I think that Willem presented that in his earlier presentation. From these algorithms to work, the model have to be trained on historical data about outcomes that have already been identified or labeled by human experts. So for example, if you want to predict a machine failure and you have 10 variables, let's say, that impact that failure, then you're going to need about 100 examples of the failure to teach your model. The benefit of machine learning is that it's fast, it's accurate about anomaly detection. Anomaly detection uses applied mathematics and machine learning to flag events as statistically significant. They are trend aware. What I mean by that is they take advantage considering the ebb and flow of data based on historical data. So for example, if you're dealing with temperature and your temperature rises at a certain time, comes back into line, rises at a certain time, comes back to line, the machine learning can see the pattern and will not consider that a failure necessarily. While rule-based systems will flag that event based on a rule as a problem, which may or may not be a problem based on your things. It is a probabilistic system that can give you wider insight into the behavior of a part, machine, or process. In other words, based on historical outcome in this situation, here's what we can say about the future. They are much easier to maintain than rule-based system. Also, if the speed of change in your business problem is high, such as the situation or scenarios or data that are changing constantly, then machine learning is a great approach over rule-based system, because with a rule-based system, as I mentioned before, you're going to be constantly updating and writing new rules. The disadvantage is that you need to have a lot of data that is in the right format, or cleansed, as people like to say. A machine learning model is really only as good as the data it absorbs. You will hear more about requirements for data in Dave from Critical Manufacturing's presentation. The third challenge is to find those programmers or engineers with the right skill sets in applied mathematics or experience in machine learning. So that's another obstacle when doing machine learning. Next slide. This chart is done by, it was done by InfoQ, and it's a simple chart with, just a couple criterias on determining what methodology is best for what attribute that is defined here. I thought it was worth sharing because I think it's a good, quick look at the various aspects of the methodologies. Interpretability, boy, if I can say that 10 times, that'd be great, is defined as the degree to which a human can consistently predict the model results. Obviously, with a rule-based system, you can interpret the cause of the decision based on the rules and the knowledge base, so it's simple to follow. As well as in machine learning, based on the model, you can interpret the results. Accuracy is the number of correct prediction data points out of all the data points. And in the formal definition, it really is defined as the number of true positives, true negatives, divided by the number of true positive, true negative, false positive, false negatives. We can say that machine learning and deep learning models' accuracy is the measurement used to determine which model is best as identifying a relationship and pattern between variables in the data set based on the input or the training data that you gave it. Maintenance is maintaining the rules. Model and deep learning models, you need to maintain the model just as you need to maintain a rule-based system, but it's much simpler to maintain a machine learning than it is a rule-based system. Speed of execution is definitely in the rule-based system because it is a decision tree. So based on the input, it traverses the tree based on that, and the execution speed is much faster than you would with a traditional machine learning or deep learning system. Next slide, please. So what I'm trying to say is that all of these methodologies have their place in predictive maintenance and manufacturing analytics. The important thing is to align your technology choice to the underlying business goal that AI was set forth to achieve in your organization. What problem are you trying to solve, or challenges are you trying to meet? A lot of what Willem had pointed out, as well as you'll hear more about this in Sid from Hitachi Ventura's presentation. So use the right tool and methodology for the job depending on your use case. Rule-based systems may be quicker to build and iterate. However, it is important to know when you want to transition from a rule-based to a machine learning system, such as when it's getting too big, too many rules, or hard to maintain. Or you can use a hybrid of all these methodologies based on your total solution. In many use cases, including weather prediction, and we can have a debate whether weather prediction is correct, especially not in Austin. However, what they do is use multiple models and they run them simultaneously, and the results are aggregated to create one final prediction. This approach is known as ensemble modeling. As additional data becomes available, the statistical model will either be validated or revised. So this is also another approach to doing predictive maintenance as well as manufacturing analytics. While machine learning's strength is the amount of data it can analyze and track in real time, a human strength is the providing context and intuition and analyzing the outliers or other edge case scenarios. That's it. Thank you. And back to you, Jeff.
Thank you very much. Very much appreciate that, Marcia. That was very insightful. It was a great perspective on how analytics can provide insight into strategies for predictive maintenance. Next up, we're going to hear from Sid Verma, who is General Manager of Manufacturing Practice at Hitachi Vantara. He specializes in the oil and gas, power utilities, and industrials manufacturing and aerospace industries. And he's going to help us understand the intelligent manufacturing journey. So without further ado, here's Sid.
Thank you very much, Jeff, and welcome everybody. This is Sid Verma representing Hitachi. I am from the manufacturing practice out of California, Hitachi Vantara. So, let's start with the new normal. I guess it's not a news to anybody. Means if you look at historically, industry shocks have brought lasting changes and shift. And you all will agree that rate of change of external factors as impacting businesses and have actually grown like exponentially fast. And list is long, but the main ones like that we feel a lot is like the supply chain shocks, the growth challenges, and the pricing pressures. And for now, in this current time, the most prominent is the current pandemic, creating a new normal for us and really transforming and ramping up our journeys into the Industry 4.0 world. For us, strategic transformation starts with the question on where to focus first for the maximum impact, and then how to scale those initial digital wins to transform operations and business models. Give you a little preview of Hitachi. I'm guessing you all know Hitachi as good as I know. It's a 110-year-old company based out of Tokyo, Japan, and it is a parent company of Hitachi Vantara, where I belong to. We have a history, 110 years of operational technology heritage across diverse industrial verticals. They were the first to bring electrical power to Japan, and over 60 plus years of information technology, which is the roots of Hitachi Vantara. We are a manufacturer at heart, and understanding of technology and ability to consult and make difference in the manufacturing around the world. Let me start with what we call the intelligent manufacturing journey. We feel it is a continuous journey. It is a journey that Hitachi has followed and learned from, and something we are proud to share with our clients, our customers, and we call it the staircase to value. Manufacturing maturity for customers are at varying level. Same is true for us. Our factories are all at different levels. Most of the manufacturers we feel are at the level 1 and 2, as you can see in the diagram. Let me see if I can. Okay. The big step change is actually the adaptation and movement to level 3 and 4, where we actually start realizing some of the customers into the manufacturing fold, and like what Willem was talking about, like jumping the predictive to prescriptive. And we are also suggesting, like, because we are a manufacturer which has a big clients and a customer base and a suppliers, to actually get a symbiotic relationship where you are sharing information that is most important to each other. We have all experienced typical environments that we play in. They are heterogeneous, varied by age, architecture, islands of automation, and places with manual data and several monolithic disconnected manufacturing systems have. I mean, if you look at a manufacturing client or a large client, typically on the IT side, they have 25 to 30 main applications. But if you jump on the OT side, like my personal experience, like from 600 to 800 applications trying to do different things. And that's like a mix of OT and IT stuff in the manufacturing and engineering side. So the challenge for us is to get insight that matters and optimize, gain control over the key pain points. Our focus here is to tackle these issues that can drive business outcomes and provide you a pathway to progressively drive maturity. Just going back to what Marcia was suggesting earlier, I mean, there is no one answer that will fit all your problems. You will have to choose the right type of analytics, and like even different kind of machines or assets or processes will need a different answer, something that has to be thought through and something where your experience will help. On this slide, we talk about the success factors based on our experience, and we feel that only a subset of industrial transformation projects, and from our experience around 11%, actually make it out from the pilot phase to a broader adoption in the organization. Therefore, it is important to look after some of the fundamentals of the processes as you approach the initiative. What we have found is that it is important to focus on what's important, setting clear goals and identifying areas that need improvement, and coming up with smaller projects that provide a proof of value and are clearly supported by the leadership team and the organization. It is also important to focus on what really matters to get results and leverage outside experience as you undertake the journey as you deem fit. On every journey, we should abide by some guiding principles, and these are the ones that have shaped our experiences. Guiding principles help in understanding where you are as an organization, taking on projects that are right-sized based on key use cases. A wholesale rip and replace strategy need to give way to leveraging what we already have in place for data integration and processes that should be expanded. Here is where a systematic approach helps, focusing on what's best for the business with specific value areas to address, and using core set of technology that can easily be reused from site to site. Then also accommodating the existing organization with good change management approaches and assessing where we have gaps in the understanding and in our ability for the workforce that needs to be addressed to. This diagram kind of helps us illustrate the different level of capability across some of the fundamental solution areas where you may fit your journey for digital transformation. This is like a step next to the value staircase, and if you are able to have really good eyesight, you'll see this small number 1, number 1.2. That's kind of aligning to the value staircase for us. So what we have done is as we went through our own journey, we have broken this journey into these capabilities. And as the number says, 1.1, 1.2, which are operationalized by what we call as a manufacturing insight suite of solution. And these 1.1, these small things like machine analytics, production analytics, quality analytics are the modules there. I mean, they are supported by our consulting services. And what we do with that is we take this application and tune it to an individual client or individual use case or individual site. And then we kind of help bring in the data science, rule-based expertise from our engineering groups and other manufacturing experts to make it operational for our clients. We are also taking a building block approach rather than a monolithic software approach as the infrastructure capabilities have moved forward, leveraging technology modules that will connect with each other, creating a digital thread of information across your organizations. These are some of the base capabilities that we found are useful in IoT project for manufacturing and help to provide ability to roll out a lot of little functionality depending on the maturity of the site, also allowing for future growth. On technology side, they are containerized microservices, which are centralized and can be deployed on-prem or on cloud of your choice. So just closing the loop on the value staircase, so this is how we suggest the clients proceed on a journey, kind of something we have learned ourselves, and we kind of break them down into modules that are applicable to each client, and then based on choosing of different rules or analytics or like what history it is, we help guide you through this. The central idea for us is to accelerate the descriptive, predictive, and the customer inclusive approach across each of the critical manufacturing operations as like asset and maintenance, production, quality, supply chain, health and safety. And as our promise is to be a trusted partner, we bring in our experiences of our intelligent manufacturing journey. Just to give you a little sample of that, these things are not slideware, but a proven record of manufacturing transformation. You'll see these machine analytics and process tracking being implemented at multiple sites, being used and constantly improved as needed. As Willems also hinted about quality tracking, which we have found a lot of the hype has, or a lot of the interest has been around predictive maintenance, but we found quality is an area where a lot of easier progress can be made, and it's an area that has not seen a lot of interest. We have been focusing on quality and digital thread. As a manufacturer, we feel that's the pain point for most of our clients too. For the manufacturing industry that is facing challenges for realizing value from transformation projects, Hitachi brings in the ability to inspire, vision, architect, and accelerate digital transformation. So what you see is a vision to value, and then from value to in production turnkey solutions, and that can actually deliver outcomes. at the lowest lifecycle cost and reduce risk. I mean, we kind of bring in the best of OT and IT expertise into something that you can see and feel tangibly in a product or in the consulting services, unlike pure technology players or pure consulting players. At Hitachi, we take digital transformation very seriously, and we have used it extensively on ourselves. We kind of say we drink our own champagne or eat our own dog food. And for that, like, we have to show our Omika Works factory in Japan has been now recognized as the only lighthouse factory, lighthouse site by World Economic Forum. It's a pretty big achievement, at least for us. And we like to share our learnings from this and help shape transformation as other clients, and also throughout our own infrastructure and factories. Just to give you an example of what we have been able to do with our suppliers and partners, we have taken this information and techniques that we have developed internally, along with millions of hours of consulting, and applied to many companies. In this example, an automotive player that shall not be named, annual production over 2 million with more than 12 factories and making almost more than 30 plus models. We actually went on a co-creation journey around our manufacturing expertise and our products to help them do real-time visualization and anomaly detection, remaining useful life and equipment failure tracking, edge analytics for real-time decision-making, and visualization and open readiness for adoption. With our co-creation and projects, the client was able to embark and make success on their transformation journey and achieving business outcomes, which led to 15% reduction in number of cars falling out of production, mostly like quality. 15% reduction in duration of assembly line downtime, a lot of it production prioritization and maintenance, and 10% reduction in cost itself. And a lot of it is like around scrap and making first time through, like a lot of the stuff Willem mentioned in his earlier presentation. So to wrap it up, in conclusion, we would like to accelerate digital industrial transformation for manufacturers, and we present a pragmatic approach and act as a trusted advisor who can coach and help during this marathon, helping pick big, bold, and use cases that can jumpstart the innovation factory and accelerate operational innovation, orchestrating human, machine, and data together as we drive this value. And if we follow a proper process and approach, there is nothing we cannot do together. That's all from my side. Over to you, Jeff.
Thanks again. That was great insight, Sid, and a really useful set of business outcomes. I was quite impressed by that. Now, having been on an intelligent manufacturing journey with Sid, we're now going to go on a manufacturing analytics journey with Bill Bither, CEO and co-founder of Machine Metrics. Bill is an experienced software entrepreneur and the founder of Italisoft, an enterprise software company that sold to Kofax, now Lexmark. Prior to that, he worked in aerospace manufacturing. And now over to you, Bill.
Great. Thank you, Jeff. Today I want to talk to you a bit about the manufacturing analytics journey and give you a little bit of introduction on Machine Metrics. So we are a team of manufacturing and software veterans that came together about 5 years ago to transform manufacturing. And we're really focused on leveraging machine data to drive automation and process improvements. And so the first thing I really wanted to cover is the current state, where we are today. We found that manufacturing equipment, machines that are worth hundreds of thousands of dollars, operate at less than 30% utilization. We know this because we've connected to thousands of these machines, and we benchmark this equipment. And it can come as quite a shock to our prospects and customers when we share this data with them. So really what this says is that the opportunity for improvement in manufacturing is significant. And despite all the innovations in machines, robotics, automation, we're really consumed today with manual processes that lead to inefficiencies. So that's why we're all here. The promise of IoT is to connect your equipment and use this data to drive efficiency. The problem is so many of these implementations have not been successful. Cisco stated a couple of years ago that 76% of these implementations fail. And really the reason is that equipment in manufacturing is so diverse, it's difficult to connect. Some have connected their machines only to find that the data isn't actionable. So many have data historians and OPC servers, but each machine has a different way that that data is structured. Existing IoT platforms are just not specialized enough. Those that have been successful really require a lot of extra work, custom development, outside integrators, and continued maintenance. So that we know that in order for the digital factory to really reach scale, this needs to be simple, offer quick time to value, and scalable. And that's why we built Machine Metrics. Sorry, I forgot to advance my slides here. There we go. Okay, so yeah, as I said, that's why we built Machine Metrics, which is manufacturing's industrial IoT platform for machines. We make it very easy to capture and transform data from machines, and then make that data actionable through increased visibility, scalable predictive analytics, and configurable workflows that automates manufacturing processes. So just quickly, we have over the past 5 years, we've connected to thousands of machines across many industries like medical device, aerospace, automotive, heavy industry, and with really a pretty strong focus in discrete manufacturing. So first, just a bit about our platform, and we'll get into the journey. So our Edge platform, as you can see here, is used to connect really any machine. Most of our customers install Machine Metrics themselves without any assistance from us. Data is collected directly from the machine's control for modern equipment, or we can add sensors to connect to legacy equipment. And this data is automatically transformed into standard data structures using our AI-driven transformation engine, so that this can be scaled across many machines, even if you have different types of machines. This data can be collected at both low and high frequencies, and this allows data scientists to develop their own custom predictive algorithms. And then these algorithms can then be deployed to the edge at scale. And then the edge can be connected to either one machine, or you can have one connected to many machines. And it's essentially managed remotely, so it can be updated automatically and really provide a very simple, scalable solution on the edge. And then on the the cloud infrastructure is, oh, this is really going ahead here. Sorry about that. So essentially the data is streamed into our cloud infrastructure. This is where that data is made available through open APIs. It's aggregated in a data lake and made available for reporting. It can be accessible to data scientists, software developers, engineers. But really, it's the out-of-the-box applications, the no-code workflow engine that allows you to add rules to kick off actions is what drives a lot of value. And then the out-of-the-box applications, like you see here, can be built from the platform. We provide numerous applications out of the box. We allow others to build applications that's then shared with other customers, and this is really what like I said, provides that actionability. And some of the use cases we support are like production monitoring, condition monitoring, predictive maintenance, and process optimization. So, but what I really wanted to get into is really the analytics journey. Now, the first step in our analytics journey really is around capturing the data. So what we do is the edge device that we talked about before needs to collect data from your machine's control or from the sensors in the machine, and that data is then made accessible through an open standard. We use a standard called MT Connect, so that every machine essentially speaks the same language. And this data, like I said, is streamed to the cloud infrastructure where we can actually apply analytics. Now, we've heard a lot about predictive analytics and prescriptive, but really there's a journey that starts at descriptive. The slide, the titles are actually missing on the slide, but step one is descriptive analytics, which is really understanding what's happening on your factory floor, what's happened in the past, and what's happening now, This is really covered by dashboards, historical reports, and quite honestly, most manufacturers don't have an adequate amount of visibility. And this is where a lot of the low-hanging fruit lies. And this is where a lot of our customers start, is with descriptive analytics. The next step really is in diagnostic analytics. This is going a little bit deeper. It's really understanding why is this current behavior occurring, and really involves a lot of machine conditions, diving in to identify bottlenecks so that corrective action can be applied to the right problem. And then beyond that is really predictive analytics. We've talked a bit about that here today. This is really about what's likely to happen based on past patterns and events. And we have seen predictive applications in quite frequently in continuous rotating machinery and process manufacturing. It's been quite elusive in discrete manufacturing due to all the changeovers that occur. And then really the next step, and we've heard the term the holy grail is in prescriptive analytics. This is really about informing the user what steps should be taken to prevent problems from occurring to begin with. And use cases that support all of these, particularly like predictive and prescriptive analytics, is that holy grail. It can cut out these manual processes and can continuously close the loop on data in real time. And at Machine Metrics, we really look at how to apply these analytics by, and actually taking action on these analytics by configuring workflows that will notify the right person or the right system to take action depending on the data from the equipment. So so let's go through a few of these use cases. And the first being really in descriptive analytics. So what we see really out of the gate is real-time dashboards that will really empower your shop floor to essentially to garner a sense of competition. One operator from one line of machines, another operator from another line of machines, having that presented to them in a dashboard that really represents goals to the actual production can really motivate your people on the shop floor to produce at a higher efficiency. And then these are fairly standard reports that you see. A lot of applications support this. Where we've actually see some additional value really is advanced benchmarking. And this is something that you can see here. The use case is really benchmarking your utilization capacity with industry data. And so what we're able to do is take information from, in aggregate from many customers, and then apply that to our customer to tell them how they're performing compared to others in the industry and how that applies to their type of equipment. And decisions can be made in terms of purchasing new equipment. Is that justified? Should we invest in our operations, or maybe bring in work from our supply chain? These are all decisions that are made based on this benchmarking data. So the next step, diagnostic analytics, really, like I said, is really around understanding root cause. By looking at the machine data directly, here's a screenshot of example of our diagnostic timeline, you can understand why the problem occurs to begin with. In this case, the use case that I'm showing here is about identifying the root cause of machine downtime with these diagnostics. And what an example that we've seen here is an operator that third shift might edit a program on the machine that causes a machine to crash. This happened at one of our customers a couple months ago. And what the supervisor was able to do remotely using the data is to look at what happened prior to this crash and quickly identified that there was an edit made to that program with a mistake. And so the supervisor was able to train this operator to make sure that doesn't happen again, and then implement standard practices so that that's not something that occurs with newer operators in the future. And this is something that was unveiled through a very deep diagnostic analytic. So going into more predictive analytics, this is a lot of talk around this, and quite frankly, there's a lot of value here. The challenge is that it's really difficult to achieve this level of analytics because it requires, one, a lot of data, a lot of history, labeled data. So you need to understand where these and when these failures occur. And but once you have that, the value can be quite significant. What we focus on machine metrics is to make this scalable, so that we have the data that's being collected at high frequencies. This allows our data scientists to detect patterns that will that then can be applied to our customers through an algorithm that runs at the edge. You can see an example here. One of the use cases that we support is really it's been discussed here is predictively detecting quality defect issues based on the activity on the machine. In this case, you can see normal cuts. This is a CNC machine. After a few cuts, you can start to see a pattern change. And if this is associated with the operator labeling this data as a failure, in this case, a cutting tool failure, we can apply that pattern to the future and really detect these issues ahead of time. In this case that I'm showing here, we're able to detect a cutting tool failure 45 minutes before it actually occurs. And during that 45 minutes, customers producing bad parts. So we can really both prevent bad quality parts from being shipped and produced, as well as preventing that tool from breaking. And this can be run at scale in real time by applying this algorithm that we've detected these patterns right to the edge. So the final step in that journey is in prescriptive analytics, and this is where we kind of pull all of the knowledge that we've gained through our descriptive, diagnostic, and predictive analytics, and really provide instructions to the operator so that we can recommend techniques to prevent these problems from continuing to occur. And an example that I like to give is here's a screenshot of our operator interface. Essentially, we're able to present instructions to the operator, help them identify when certain problems occur. For example, if we're producing a part at a particular cycle time, and that cycle time changes, we can detect that changes. That's that's really just looking at the data that's being presented, but then offer a suggestion. Look at where in the program did that change occur, and highlight to the user where they should fix that program. And if that can be done really on the spot in real time, it can save really hours and in many cases days of time to really get to that root cause and actually solve that problem. And there's many use cases where we can apply prescriptive analytics, but it involves a lot of domain knowledge and really just expertise and time to understand where these problems occur. So so really, I wanted to conclude here, going through the full analytics journey with some key takeaways. What we found is that number one, that data is really critical. It's critical to have your data in a format that's understandable, where you can apply analytics. And that's often where these projects fail, is just accessing this data in a way that's consumable, capturing, transforming, and adding context to that. And that's something that we've really put a lot of effort into making sure that that's simple. Once you have that data, then it's really around starting simple, starting with the dashboards or reports of simple analytics, and then learning over time to move through the analytics journey. You want to make sure that you have that internal champion. Who is responsible on your team? If a few of the failures that we've seen, that champion changes and there's nobody else assigned, and the project starts to stall. So that's the other is really taking action on the data. You really want to make sure that you aren't just consuming the data, you aren't just showing dashboards, that you're able to apply action. And that's really the some advice that I can give on making sure that your IoT projects are successful. And with that, I'll leave it to Jeff, and happy to answer any questions that come up. Thank you very much.
Thanks so much, Phil. Great advice and insight. And I really like that cutting tool example. and your advice about starting small and not tackling too much at once. So now we're going to turn to our last speaker, Dave Trail, who's Vice President of Sales for the SMT and Electronics Business Unit of Critical Manufacturing. Dave has more than 25 years of experience in electronics manufacturing, equipment, processes, and manufacturing execution system software. Throughout his career, Dave's been a pioneer and a proponent of the evolution of manufacturing from Industry 3.0 to Industry 4.0, big data analytics, and IIoT. And now he's going to provide us with his insights on analytics and big data and how it underscores Industry 4.0. It's all yours, Dave.
Great, thanks, Jeff. See here. All right, so as Jeff mentioned, I come from an MES background, and I think that's somewhat important for the purpose of this conversation, because I kind of get a broad view of manufacturing as a whole, and my focus on SMT and electronics and semiconductor gives me a unique view also on the processes of manufacturing very tiny devices where billions and billions of transactions are taking place per second, being able to process those and being able to do something with the data. So a lot of what I'm going to talk about is going to be about data. Basically, MES is important because connecting all of the information in the factories, both internally and externally, is essential for whatever you're going to want to do when you start talking about analytics, big data, or Industry 4.0. First being connecting all of the assets. This could be all of the pieces of equipment, all of the processes, all of the people and things and materials, all into one cohesive system, and normalizing that data after it's collected to make it actionable. MES is used to plan and control production in real time. The system obviously has to be integrated into ERP, sometimes PLM, other systems that are being used by organizations. But MES is extremely critical when it comes to manufacturing and the manufacturing floor, and you have to digitize everything. Not just the internal processes or machines or ever, but one of the premises of Industry 4.0 is digitizing the entire supply chain as well. So as I mentioned, data is king in this, and this is an area of focus that we spend quite a bit of time on, and we're coming out with some pretty exciting advanced technologies for being able to bring in, these billions of data points per second and be able to manage that data in a way that is both economical and usable. There were statements that came out a few years ago called "data is the new oil," and there's a lot of people saying this for quite a long time. And then about 3 or 4 years ago, some of the journalists, in our field, they started obscuring that term, and they started talking about how, data, can't necessarily be, the new oil, because, people are not going to necessarily pay for other people's data. And that was the interpretation that they had when they started talking about data being the new oil. My understanding of this now, and kind of how I look at it, is yes, data is the new oil, but not because it's something that could be sold to a marketplace for profit. It's more has to do with how that data is locked into this giant treasure trove of your manufacturing floor, and all of the data that's being produced that is mostly untapped, unrefined, and sometimes inaccessible. In your factory, it's probably one of your largest assets that you have that perhaps you're not even really paying attention to. We believe that utilization of this data benefits any organization and helping them produce basically a better business for themselves. So, one of the, leaders and pioneers in the philosophy of continuous improvement and thought within manufacturing had a pretty wise phrase here: without data, you're just another opinion. And I kind of like that, and I use that phrase quite a bit. So for the purpose of my presentation, let's go with the assumption that data is important. I think we can kind of all agree upon that. So let's build upon that premise. There's 4 levels of the smart factory evolution. first being just the available data. It's typically in silos. Sometimes it requires a lot of work to be able to get that information out of your various pieces of equipment or systems or software, et cetera. Translating that into something useful and allows a little bit of problem solving in running your business. Accessible data, which is level 2, does integrate all of these different data sources into a single source of truth and continuously gathers and tracks all of this production data. As you move into level 3, you start going from reactive problem solving to more of a proactive analysis and improvements, and adding various capabilities such as some artificial intelligence premises such as machine learning, et cetera. And ultimately, level 4, which is closed loop artificial intelligence, controlling your production line, optimizing various parts of your process, generating information, analyzing that information, and changing the settings on the machines, et cetera. This is where things happen automatically. And there's only a handful of companies that are actually using a high degree of machine learning in their factories. And what we've learned in working with some of these companies is there's really no shortcut here. You have to start at level 1 and grow your capabilities, throughout all of these 4 processes, or else you're kind of destined for failure. When we start talking about all of the data that is coming from these manufacturing floors, we start talking in numbers that most of us aren't very familiar with. Zettabytes, which is kind of something new for a lot of people, that term. And as you look at this, you start seeing all of the data that's trapped in most factories, and the numbers are just absolutely astounding. And what's particularly interesting about this is when you start looking about all of the trapped data, in zettabytes, out to 2025, and the major restriction, which is the available IP bandwidth. So we need to, figure out a better way to utilize all of this data that is available, and also, a way that we can store it as well. So that kind of brings us to a couple different possibilities. You could scale up, taking what we're calling big data, and all of this massive volume of information, whether it be structured or unstructured, and basically add on to your capabilities within your factory, adding servers, improving your data pipelines, et cetera. But that's pretty difficult to do once you start getting to a different stage. Most enterprise systems are now starting to look at scale out, and that's what a lot of people are talking about now, and that's some of the promises of the cloud, which is being looked at in manufacturing. However, there are some limitations to that as well, because some companies believe that they don't want their data on the cloud because of security restrictions, et cetera. But the good news is that technology is trying to keep up. This was an interesting chart that was put together a few years ago, and what it's showing is calculations per second per $1,000 spent across the years. And what it is explaining is the exponential growth of computing and brain power. And brain power is important, especially if you start looking at the boxes over on the right here. Around 2008 or so, these calculations per second per $1,000 chipset or investment in technology was able to give you the intelligence of an insect brain. I mean, that has rapidly grown beyond, a thinking process that's typically done in a mouse, and all of the processes that occur there. And if you look at the acceleration along this curve, this is where it starts to get pretty exciting. In about 5 to 10 years or so, we're going to have the computing power that is going to be equivalent of one human brain captured in a $1,000 investment. And very shortly after that, technology is evolving to such a level that we're going to be able to encapsulate all of the computing power of all human brains combined together in one single chipset. So, I mentioned cloud data, and I'm not going to spend a ton of time on this due to time restrictions. Just for your information, this presentation is typically about an hour long, and I'm trying to condense it into 15 minutes. Basically, the idea here is to improve the efficiency of your data gathering and all of the data being transported within your factory. Collecting it through sensors and controllers, doing some processing on the edge layer, speeding up some of the data transfer both in and out to the various devices that are connected to the sensors and controllers. The fog layer is basically a local area network. That's where a lot of companies are right now. And then as the company evolves, they start looking into a cloud layer. And this is where some of the large data processing can occur, in addition to smart ways to warehouse all of that data and make it usable to most people. What we're talking about here is obviously, we're building upon the analytics part of things. And what we're showing is, both real-time and batch processing, and areas that, when you're online, things can act such as historians or trends. You can pick up alarms or set alarms. Advanced analytics give you the capability to have interactive dashboards, customize various metrics, and measure some of your KPIs, and allow some complex processing of the data that you're getting. Beyond that is reactive analytics, and this is where you're taking some of the data that you have that you've aggregated, and you're able to slice and dice it and create statistics, et cetera, all the way up into predictive analytics, and using machine learning for models and simulations, and really where you start processing some of this big data that we're talking about. And to build upon that, advanced analytics, I like this chart here because it does a very good job of explaining, how data and analytics, come to play with machine learning and big data. Obviously, as you go out on these various scales, you're moving more into a machine learning capability, and you combine that with what type of data inputs that you have, providing answers, anything from old answers to old questions, all the way up to really utilizing big data to feed into machine learning, where you could start getting some new answers to new questions that sometimes you haven't even considered, because the machine is reacting based upon the information that has been gathered. But that's not without its difficulties. We've spent a lot of time talking about various types of analytics, whether it be descriptive or predictive or diagnostic or really transformational analytics. The level of difficulty in working with this data tends to grow exponentially as you move from one side of the screen to the other. However, the benefits that you start to get from this, where you're basically just translating raw data, and turning that into some type of information that you're putting into spreadsheets and things like that to gather some intelligence from, all the way up into, where you're doing transformational analytics, where you're really able to start deriving optimal business processes based upon the use of the data and analytics that you have within your factory. So, when you put these presentations together, I like to put together some quotes occasionally. And, originally when Pablo Picasso came up with this quote, it was pretty accurate. He was saying that computers are kind of useless. They can only give you answers. And, these days, some writers and industry experts kind of scoff at that. And it's kind of a joke in a sense that, oh, he didn't know what he was talking about, but the fact is he did know what he was talking about, but that was just 50 years ago. Today, I interpret this more as a tongue-in-cheek type quote, because the answers that you get, they're both real, measurable, they're financially significant, and in general can be the difference between success and failure in a modern world and in a modern manufacturing environment. So moving on here, we've spent a lot of time on analytics, and I also mentioned a little bit about big data. all of this starts to bring us into one of the hottest areas of artificial intelligence or data utilization, which is machine learning. There's been a lot that's been mentioned on this on the presentations previous, but you know, this is a pretty exciting field, and it's not necessarily as ominous or concerning as, you know, some of the science fiction writers or movies that we see are, because I do not believe that machine learning and artificial intelligence is going to take over the world. I think it's just going to be able to augment a lot of what we're doing. And as individuals, you know, we are captivated by this. You know, what this chart is showing is the search trends over a period of time where, you know, big data, you know, everybody kind of has an interest in it, but they're having more and more of a tough time tackling that. So it really hasn't taken off the way that some other technologies have. Whereas when you look at machine learning, people are starting to really see the value behind this, because machine learning is now able to start providing real benefits to organizations, both through cost reduction, OEE improvements, ultimately increase in margins for companies. And, you know, machine learning applications, you know, as I mentioned before, you know, a lot of this is done in the context of an operator or a person working within these various sectors of both supervised, unsupervised, and reinforcement machine learning applications. We've heard some pretty good discussions about, you know, what machine learning is and how it can be used. This slide here is basically just talking about some of the general principles of machine learning and some of the benefits and things that you can do with it, anywhere from silly things like playing games all the way up to, you know, medical imaging, where we're starting to capture some diseases and some problems in people based upon the information that some of these computers and information has gathered over the years, really being able to make some really unique observations and predictions. Machine learning in manufacturing also follows the same principles of supervised, unsupervised, and reinforcement. Supervised learning can do things like cycle time prediction, some diagnostic and maintenance information. Reinforcement can be used in things like robotics. We're seeing more and more of that. Even traditionally in you know, some of the areas of the world that relied upon lower labor, they're now going towards robotics as well, because the complexity of the things that we're building are really growing exponentially, and all the way out to unsupervised machine learning, which could do things such as clustering yield, predicting failure modes, and doing some visualization, not just of the minor data collection, but, you know, some visualization of some of these big processes. So, sorry about that. Now, where is Industry 4.0 and you know, IIoT going to contribute over the next coming years? Along the left, you'll see some areas that companies are using various aspects of these technologies. Talking about also what's in use today, anywhere from you know, 28% of the companies are using some sort of predictive maintenance, and some companies are 52% of them are using data-enabled resource optimization. But what's going to change over the next 5 years are all of these, you know, areas that we're talking about with the arrows. And MES, which is, as you remember, the angle that I'm looking at this on, are areas that, you know, is going to be involved in the dramatic increase of these Industry 4.0 technologies, principles, and utilizations. Now, sorry about that. So some applications in manufacturing that we're seeing: detection of anomalies, classification of you know, situations and failures, and being able to look for interactions between various categories to determine how all of those go together to you know, solve a problem. With enough data, you know, we were able to start doing things like probability. and how changes to specific variables are going to affect the outcomes of your manufacturing floor. How making these changes is really going to change things on how you do things and where to make your adjustments, all the way up into optimization, where intelligent systems can then calculate probabilities on their own and make their own adjustments accordingly, such as things like reduce machine speed if sensors start determining that you're having problems on a specific set of products that you're running at that particular moment. So kind of, you know, I went through a lot of data, and as I mentioned, a lot of this is pretty, you know, important stuff. And we've talked, you know, about, you know, some big data, some smart technologies. Perhaps some of you are a little bit confused. I tend to talk a little bit fast sometimes. But kind of what all this boils down to is a question that you should be asking yourself. Is all of this and all of what I've listened to today, is this important to me? I think most of us will agree that yes, it is pretty important. And with that assumption is, okay, so what do I do, you know, to move in these types of directions? What happens if I don't? And some people are looking at this and saying, oh, this is too big or too complicated, confusing. There's got to be some alternatives to chasing this down, you know, this rabbit hole that we're talking about. It's important, as everybody else said, that you do put a strategy in place. First, you need to be able to map all of your processes. Skipping on me here, so. Being able to map all of your physical business processes, things like visibility and traceability. This is where you start monitoring some of your KPIs. Second phase is starting to put in some of your control loops, enforcing different processes or rules, making some decisions based upon SBC and real-time reactions, really getting your process under control. Moving into the optimization phase, or the third step on this, where you start doing things like changing the scheduling of your manufacturing plant, or changing how you do things based on the information that you're gathering. And then ultimately really achieving the fourth level of good smart manufacturing implementation strategy, which is what we call excelling, which is utilization of things like artificial intelligence and machine learning. Now, you know, we've talked about the four strategies. Let's talk about now the how. How do we do this? One of the most critical aspects of this is the people. And I do not believe that this can be run from a bottom-down philosophy. This can't be something spearheaded by an IT department or by the manufacturing division or the designers or the electrical engineers. Top management really needs to buy into this. Okay, it can be introduced, or it can be discussed, you know, from IT or some of these other areas, but because this is such an important concept for most manufacturing organizations, it has to come down from the top, because there has to be a total buy-in from this, and you know, you have to have the right people in place. So implementing digital manufacturing, you know, requires building a digital workforce. Technology is also a key part of this. Companies make smarter decisions using things like predictive analytics and machine learning. You start using things like digital twin or augmented reality. And this starts driving leaner and more productive operations. So the first question is, all right, so based on this information, what is my ROI? This is kind of a hiccup that a lot of people get involved in, because some people tell their top management, okay, you're going to pay this off in 9 months or a year. They're really, you know, that's kind of a lie in a way, and kind of a sales strategy that's used by some. Most of the time, because this is such a transformational process that does yield some good results over the long term, most ROI occurs in the 3 to 4 or 5 year time frame. So there really is no quick payback, but there is a substantial payback if you bear with it. One of the other quotes that I like to put into this is one by Jack Immelt. And I think this is extremely accurate given what we're seeing today and why a lot of us are at this seminar today. What he said is, if you woke up as an industrial company today, tomorrow you're going to wake up as a software and analytics company, because software analytics driving all of this change is really what's going to dictate which companies succeed, which companies fail, and how all of that works together. Additionally, here I am going to contradict some of my other panelists here, because I don't believe that this could be incremental. I don't think that you can just bite off little chunks of this, because all of the other incumbents, all of your competitors, all of the other people looking at this, chances are ahead of you already in this. And your business model and the future of your company as a digital company, and it's just too great, and the environment is changing way too quickly. So this requires bold, inventive, and strategic plans to really make things work. Now, why aren't people doing this? And these are the main barriers to digital transformation. And as you start looking at this list, things like priority conflicts, or I don't really have a good digital strategy, or I'm worried about security, or I don't know if my organization can really do this. When I looked at this chart and I kind of boil all that down, is I kind of get that people are looking at this, and this is an actual review done by MIT. They're basically saying, I'm kind of too busy to worry about this stuff, or it's not really a big deal, or I have bigger fish to fry. And I'm really focused on satisfying next week's requirements to get those reports or this yield to my boss. And I think that's a vital and critical mistake that a lot of organizations are making. Why? Transformation does occur. And right now we are deep in a digital transformation process that is affecting all aspects of manufacturing. And if you look at, actual Fortune 500 companies that are listed right now, back in 2000, less than 48% of the companies that were on the Fortune 500 are still on the Fortune 500 today. You go back 25 years, only 12% of those companies are still on there. And in 10 years, less than 50% of the Fortune 500 companies that are listed now are going to be on that list. Why? Because change happens, transformation happens, business models happen, and a digital strategy is going to be a big contributor into how all of this evolves over the years, and whether or not your organization is on that top list or has been moved to the bottom. And kind of a scary part about this is the gap keeps on widening. Right now, 23 times more customers are acquired by data-driven organizations. Think about that for a second. Are you a data-driven organization? Is it possible that your competition is? Are they gaining 23% more customers than you, and where are they coming from? Hopefully not from you. And data scientist jobs are really increasing. We have some brilliant people both coming up through our educational system and people coming to our country to contribute to this digital transformation. And obviously, IoT devices are exploding right now. By the end of this year, there will be 9.9 billion IoT devices connected to the internet and being used. And how does all this fit into what most organizations have? One of the biggest obstacles that companies are having is their current IT systems cannot, handle this type of data, this type of change. So that's another reason why it really takes a top-down approach in how you look at this. Now, I kind of believe that, if you haven't started the execution process now, you really, do need to start it tomorrow. When to execute. This is interesting as well, because 33% of executives polled have plans, but they don't really plan on doing much in the next 12 months. Almost half of them haven't really started doing anything yet along with this process. And, you know, additionally, let me see if I can go back to my previous slide there. 85% of CEOs really believe that they have to do something, but they haven't done anything yet. So moving back here, this is another quote that I really like. Mario Andretti, for those of you that don't know, he's one of the best race car drivers that ever occurred. And, you know, we believe that, you know, this is something that you do need to jump into, and you do need to really commit to this, and you need to move forward. And, you know, it's not something that you can waste your time for. But there is an alternative to digitization. You can't hide from it. And, you know, perhaps you'll be around in the next 20 years, perhaps you're not. But I truly believe that digital transformation is occurring. Digitization is going to change how we do things. And all of this can and will be handled by the most advanced companies using the best technologies housed within an MES system. So thank you very much, everyone. I appreciate you sticking around for my presentation.
Thanks so much, Dave. I have to say, I like a presentation that includes a Picasso quote.
Thanks.
And it's interesting your recommendation about top management involvement, which was echoed in one of the comments from a listener to Willem's presentation earlier. We had, when we shared the poll, somebody said that 38% will fail because IT shouldn't be driving digital transformations. And that was in response to showing the huge number of IT people who were involved in the digital transformation. And this person was saying IT should be part of it, but they shouldn't drive it. And with that, I'm going to turn to some of the questions. And I'm going to start with one for Willem, and then everybody else can feel free to jump in. So Willem, the question is, how do you manage change with iterations happening in a matter of hours and days versus at least a couple of weeks?
How do you manage it, or how do you make that happen?
I think it's how do you manage the kinds of change that analytics are going to bring about?
So a couple of the key things that we've seen is that you can really speed up the amount of PDCA cycles that you can do if you're trying to improve products or bring new products to market. We've seen customers who've been able to change their recipes to, you know, make things at over 100% increase in speed with maintained quality through actually being able to do much faster iterations of what are the optimal process settings. So I think the thing that allows us to have that quick iteration cycle in the machine learning pipeline is really kind of the entire backend infrastructure of how we contextualize, structure, and store the data, how we take domain knowledge from the engineers or from the users or from the industry and codify that into our taxonomy, and so that we can launch these applications that we've built as products and not as consultancy projects. Because whenever we launch a new golden run optimization, we don't do it for each customer as a new job. It's a product that we configure that we launch. And that's how we can then have, you know, very quick iteration cycles on them.
Great, thank you for that. And I would throw that out to the rest of the panel in terms of agility. You know, we're getting a lot of insight from the analytics, but the insight's coming thick and fast. So how do we respond to it in a timely fashion? So Marcia, do you want to jump in?
Yeah, I mean, if I understood the question, what you're asking is the data's coming in quickly, the model is it was developed, and now you're starting to see it having to be retrained. Is that what I'm understanding you're asking me?
Yeah, and I think implicit in that is also organizations are may not be set up to react as quickly as this allows.
Well, I know. I think one of the things, the way I like to look at it is organizations, before they venture into something like this, they really have to figure out the impact of the solution. What are they trying to achieve? So you have to have a very clear goal with steps to achieve it. And then can they afford to experiment, right? Because remember, sometimes they fail. And they have to, what is the predicted payback? So is it worth venturing down this based on the payback? It's not just technology for technology's sake, right? And so for me, I think you have to really have a clear understanding, like if you're going to try and solve predictive maintenance, what is the type of error to identify? Do you have the data for that error? And then from there, how do you identify the error and where to identify these errors? So I think that you need to really have a clear picture before venturing down into this. I think, did I answer your question?
Yep, no, that's great. Thank you. And I'm afraid we're actually at the top of the hour here, so we're going to have to wrap up. But we had so many great questions from people, and what I'll do is I will pass those out to all of the panelists so that they can get back to people where they're relevant to them. And as we wrap up, I'd like to
just
thank
a little bit. You got 10 more minutes if you like to take them. So go ahead.
We do. Okay. Yeah. Well, that is fantastic. That is good to know, Lucien. Well, in that case, I am going to pass that question back out to the rest of the panel. Bill, do you want to jump on that question about agility and organizational response to the kind of action that may be impelled by the analytics?
Take myself off mute. Yeah, I think like Marcy, I mean, the agility, having machine learning, pattern recognition that doesn't require you continuously adjusting thresholds is really important. We've seen, we support a lot of the rules-based notifications as well, and that can work sometimes it doesn't. So if that's really the sort of the point of the question, I would agree that you really want to leverage the more sophisticated algorithms or machine learning if you can, so that you don't have to continuously tweak and adjust. We look to minimize the amount of I guess operator input and just manual interaction for cases like that.
Agreed with that. But also, if you think about the question differently, in terms of what were you doing without analytics, or what were you doing without any digital tools, then you're really on the back of your heels when you're trying to react. Whether if you have these tools, you have the visibility, you know what to expect from them, then you're on your toes. So are you on your heels or are you on your toes? Yeah,
that's a good way of putting it. Sid or Dave, do you want to chime in with any other thoughts on this question?
Yeah, just a quick contribution, which kind of tails into the final part of my presentation is, this is a transformational process. This will change how an organization runs, and you need to make sure that you have the right people on board to do that. The right people, have to be agile enough to be able to do that. You need to have creative enough people running these projects and running the organization that are able to see the benefits on this. And, it isn't a situation where you can hide from these problems or think, yeah, I don't need to worry about this year. We can worry about it next. Organizations that are going to be successful going into the future will be agile. They'll be able to see the benefits behind this. They'll be able to start using some of the advanced technologies, for storing and analyzing all this data. Things like Apache Spark and Kafka and Ignite to be able to stream a lot of this data and capture dark data, which is a whole other topic that we could get to on a later date, on really being able to utilize this information going forward.
Great, thank you for that. Sid, did you want to offer some thoughts on this?
Sure. So from my point of view, this has to be actually embedded into the organization itself. We talk about using analytics to, like rule-based or otherwise, to give notification, but there are people on the field who are actually supposed to take action when they get it. And things change that they are not actually advised sometimes. And we need to put that in the organizational structure. So if you can imagine, MES, as Dave was mentioning, is the owner of what needs to happen when. And that information is typically passed on as a recipe or as a work instruction to either the machine or the people. The analytic functions are typically run on the side, and they are maybe they're doing tool analysis or rest of life analysis. If that information is not told to them that now you're actually cutting butter versus you were cutting metal, it's going to give all sorts of advice that And if I have to follow Willem, it's like, look here, look now. He's like, it's supposed he's doing the right thing. It's like all the indications are wrong. So that loop sometimes get missed, that we actually set up the data side and analytics side separate to the MES and the PLM side of the world. And that link is very expensive to build. Only big companies which have experimented have tried it. The smaller companies tend to do both of them real time. Right. So my experience at Hitachi and my other clients have been, we try to put it in the process. So when you do a shift change and you actually start making something a little bit different, you have to use the right algorithm. So what we use, like analytic lifecycle. So you have software lifecycle, we started using analytic lifecycle. So you need to choose the right tool, and good or bad for our business, the analytics usually never last too long because something changes, you like it or not, you have to retrain it. So organizationally, we keep the operational analytics team separate from the design engineering team. So we give them a separate place called Analytic Workbench, where they get all the data and they create analytics. The operations people get to choose what to run based on the shifts. So that's how we have embedded agility and used analytics in real time, practically. Because otherwise, the worlds are disconnected, and people who are looking there and seeing everything is working right while analytical algorithm is giving wrong answers, kind of like, I'm not going to use it tomorrow. So that's how we deal with it. And the people who are doing it are different people, as organizationally, you know. Analytic Workbench people are data science or engineers. The people who are on operations are different. And people who are operators are different. So they all need to be trained to use the right thing at the right place.
Yeah, and I think a lot of that depends on context as well. I mean, certainly what we see in our business is we're working with frontline teams, and what you want them to be able to see, have access to, and take action on is going to be different than middle management or senior management. So having context on who is accessing the data, what kind of insights they want to get from it, and where you want to go with it, I think is important. It also leads to another question, which we've got from one of our listeners, who is asking how we have a discussion on ROI before the implementation of the analytics. Maybe we can start that off with you, Sid, and get to the rest of the panel.
Oh yeah, I missed the question again. I got a couple of pings.
That's okay. No, just a question about ROI. So, you know, before anybody makes a big investment in analytics, they're going to want to understand, well, what kind of ROI am I going to have? You had some great data in your presentation about ROI, but how do you get to that? How are you getting to those numbers? And what did you need to set up to measure beforehand? Because you don't get ROI if you don't have a good picture of the before.
Correct. Means it's a difficult thing to do practically. It's easy to talk about on a slide. So a lot of it, the ROI is actually thinking and planning for, I'm going to make a change, which is materially going to make the process better, or a work thing better. So you plan in the beginning of change, transformation, or a project that will create a value. Then you start using the technology and process to do that thing. And we have this benefit realization. So usually when we do a POC, we look at technically we got it, but also we look at, are we actually getting that value we said before we scale in? And so that's how we look at it. Usually what we have a leverage is, having done this 500 times across the company, we know what patterns work and what value have been created before. So a lot of us is like, we try experimenting with the best knowledge at the current state. We do it like many times, then we learn, and then we go next time to the client, say, hey, this one won't actually work. When you try to do a paint shop optimization using prophecy, difficult, maybe try a different way. And that's how it is. A little bit of experience, a little bit of analytics, and a lot of planning, and never lose focus on, are you getting the value that you promised yourself, which kind of get lost in the shiny answers in technology sometimes.
Right. And Willem, given that question was originally for you, what are your thoughts on ROI and how you spec the ROI?
Yeah, we've seen that. I mean, new prospects have a very hard time subscribing to, you know, someone else's case study or results, especially if they're in another industry. Because if you go there and you're going to tell them that you're going to drive 20% increase in yield, they're going to laugh at you. Or even if you say, I'm going to drive 5% OEE improvement, and you show them how many dollars that equates to, it just ends up looking ridiculous in a lot of cases, and you don't really gain trust. So what we've actually done, which we've seen to be successful, is that we do a free pilot, a free POC, where we ingest the data and we run some of these models that we know drive real quantifiable ROI or actions that they can take. And we show them what their potential ROI is and the actions they can take to get it before having to spend $1 with us. Because then you end up with just a much more concrete discussion, because otherwise you're arguing over, you know, why this case study doesn't relate to this business, even though they are in the same industry, or even, you know, OEE is OEE, even in different verticals. So we just try to ingest the customer's own data and actually find what is the improvement potential. And it isn't the full ROI, but it's enough to at least have a concrete discussion about the cost saving.
Yeah, so almost a door opening ROI.
Correct.
Yeah.
Yeah,
Bill,
we
you
actually
look like
do.
you got something to say.
Yeah, we actually take a little different approach in that we look to start with some of the low-hanging fruit. So that's generally not predictive analytics. You know, in some small cases you can start there, but typically it's more about the visibility of your data, the transformation of that, providing some you know, simpler use cases that allows that in itself proves out the ROI very early. And for us as a company, you know, convinces our customers to expand very quickly, and then the predictive use cases come usually a little bit later.
Right. Yeah, and actually that leads to a question that we had for Marcia, and that was around on one of your slides talking about POCs. You had some data around 89% of projects don't come out of POC stage.
Oh, that wasn't me, but
oh, okay.
I do believe that was Sid. Yeah, I was about to say, I think that was Sid. So that wasn't me. So go ahead, Sid.
Well, no, I mean, it was really just around, are there things that people could do, best practices in terms of setting up POCs
Right.
so that you don't have that kind of failure rate?
Right. So normally my target market is machine builders. So machine builders tend to, what they're trying to do is be able to do machine as a service their machine remotely, offering that as an add-on. So for us, it's very compartmentalized, right? Because they know their machine better than anyone else. They know the failure rate, they know the issues, right? So what they're trying to do is get revenue from maintenance, right? So my target market, we tend to be, it's very, a lot easier because it's a very set data, right? So we also do the OEE and the analytics because a lot of times they want to see that and the customer wants to see that as well. But we also work with them. So for us, it's a little bit more compartmentalized than some of the other people speaking here. But Sid, go ahead.
From my side, Jeff, like it's a little bit of experience. So I was in consulting for a long time. And one of the good things that we learned about Agile is like, you know, you're trying to solve the problem as you develop it. But on the people who are delivering Agile, they tend to misuse MVPs to solve the simplest part of the problem. And so the POC starts with good intentions, good ROI plan. And when you go in, you see complexity, you abstract it and make it a simplest thing. So you can actually go back and tell the leader, if you simplify it, this MVP will create value. But when you try not to solve for the most difficult parts, when you try to scale it, it becomes the ROI, the investment requirement is so huge. I'm like, the data is, okay, in the simplified client version is good. But if you try to extrapolate it, like it's not easy. And that is why the appetite from leadership kind of disappeared when the roadmaps become very long and the expectation of investment becomes long. Although in POC, it looked great. I mean,
Right.
Usually the investment and complexity, as everybody has seen, no factory looks like one thing. Machine builders might be a little lucky because they have a machine, but over 30 years, they also like have so much history. And that is why most of the POCs kind of get stuck. It's not like they were all started with good intention. They solved a good problem, but they simplified all the difficult part. And that, I mean, that's my overall 5 to 6 years of journey that I have seen. It's getting much better where we kind of come with like, hey, we have done this few times. It's not going to be that easy. MES cannot be replaced by like an IoT platform tomorrow and you can run it in an auto. It's not going to happen. Like you have to start understanding what the reality is.
Well, thank you for that. And at this point, I will have to wrap it up, but I'd like to thank again our sponsors, Hitachi Vantara and Odin Technologies. And I'd like to invite you to get in touch with any of us, either at the email addresses we provided or through the conference platform. I'm now going to hand over to the next panel, which is where to start with IIoT and the true cost of integrating IIoT into your business. Thanks again to everyone.
Thank you all for
Thank
joining,
you.
and please
Thank you.
join the appropriate session for the next track. Thank you.